Here's a lesson on sine law. When solving for sides or angles in triangles, there's four main tools that can be used. Pythagorean theorem and SOHCAHTOA are special tools that can only be used with right triangles. And remember, right triangles are triangles that have a 90-degree angle. There are two other tools, sine law and cosine law, that can be used with right triangles as well, but they can also be used with non-right angle triangles. We call those oblique triangles. So sine law and cosine law can be used with right and oblique triangles. In this lesson, we're going to be focusing specifically on sine law. And I have this chart here that shows you the four rules, when we're allowed to use them, and what they're used for. So once again, Pythagorean theorem and SOHCAHTOA, you're only allowed to use those if you have a right angle triangle. Sine law and cosine law work for any type of triangle. We don't typically use them if we have a right angle triangle because SOHCAHTOA and Pythagorean theorem are easier, but they technically do work for those. We typically mainly use them when we have an oblique triangle, a triangle without a right angle. And let's focus in specifically on sine law. Sine law can be used to find an angle if we know two sides and an angle opposite one of those two sides. Or it can be used to find a side length if we know one side length and all three angles of a triangle. And then you can see here what the sine law is. It tells us that a over sine A equals b over sine B equals c over sine C. Remember, a lowercase letter represents a side and an uppercase letter represents an angle. And side A would be across from angle A. So the ratio of the length of side A divided by sine of angle A is going to be equal to the ratios of b over sine B and c over sine C. So all the ratios are equal, and we can use that property to be able to solve for sides and angles in an oblique triangle. Before we start using that sine law, let me prove to you where it comes from. So I have an acute triangle here. When two angles and a side are given, the other side can be found using the sine law, which can be developed as follows. It tells us step one in triangle ABC is to draw line AD perpendicular to BC. AD is going to be the altitude or the height of triangle ABC. So let me draw the altitude from vertex A of this triangle. And I know AD is perpendicular to BC, so let me label this point here D. I know it's perpendicular, so I'll draw a 90-degree angle there. And this, it wants us to call that the height H of the triangle. So I'll label this side length H. I'm actually going to do the exact same thing in the other triangle I have as well. In this triangle, I'm also going to label side AB. I'm going to call that side C because that's across from angle C. I'll do that in this triangle down here as well. And I'm going to label side AC. I'm going to label that as B because that's across from angle B. All right, now let's focus in on the triangle on the left, triangle ABD. Looking at that triangle I've highlighted, notice it's a right angle triangle. So with right angle triangles, we can use SOHCAHTOA. And I'm going to come up with an equation that shows the relationship between H and C. So from angle B, if angle B is my reference angle, side H is opposite from it, and side C is the hypotenuse. And if you remember SOHCAHTOA, the ratio that has opposite and hypotenuse is sine. So I can say that sine from angle B would be equal to the opposite side, which is H, over the hypotenuse, which is C. And let me actually isolate H in this equation by multiplying C to the other side. So I have C times sine B equals H. Good. Now let me look at the triangle on the right side, triangle ACD. Notice that triangle is also a right triangle, so I could use SOHCAHTOA. And to get an equation that shows the relationship between H and B this time, I can make C my reference angle, and from angle C, side H is opposite from it, and side B is the hypotenuse. So once again, the ratio that involves opposite and hypotenuse is sine. So I could say sine from angle C would be equal to the opposite side, H, over the hypotenuse, B. And then once again, I'll isolate H. I'll multiply B to the other side. So B times sine c equals h. Notice I came up with two equivalent expressions for h. Apparently h equals c sine b, and h also equals b sine c. So what I could say is that c sine b is equal to b sine c. Since they are both equal to h, they must be equal to each other. And then let me algebraically manipulate this a little bit. I'm going to divide the sine b to the right side and divide the sine c to the left side. So I'd have c over sine c equals b over sine b. So there is one part of the sine law equation. Notice it tells me that c over sine c equals b over sine b. If I drew the altitude from a different vertex, like if I drew it from vertex b or from vertex c instead of from vertex a, I could come up with an equivalent expression for one of the other pairs I could make between a side and the sine of its opposite angle. So if we took the time to do that, we would figure out that any side divided by the sine of its opposite angle is going to give us an equivalent ratio. So a over sine a would be equal to b over sine b, which would be equal to c over sine c. Now the sides and angles don't always have to be a, b, and c. It's just important that in any of the ratios that you're creating, the side is opposite from the angle. So it's always a side divided by sine of its opposite angle. I put a note here, even though there are three parts to this equation, right? We have three ratios that are equal. You're only ever going to use two parts at a time. The choice of which two to use depends on what information is given in the question. Make sure whatever equation you create only has one unknown. If you create an equation with more than one unknown, you're not going to be able to solve it. So let's see how this works. Notice example 1 says find the measure of each indicated side. Part A says find the length of side C. If we look at this triangle, it's an oblique triangle, right? There's no right angle, so we can't use SOHCAHTOA, we can't use Pythagorean theorem. We're allowed to use sine law. And let's make sure this triangle meets the conditions for when to use sine law. We're allowed to use sine law to find a side if we know all the angles of a triangle and one of the other sides. Now, I only see two of the angles given to me here, but if you know two angles in a triangle, you really know all three because we know all three angles have to add up to 180. So angle A, if I did 180 minus 62 minus 52, I would get 66 degrees. I'm not actually going to need that for this question, but it doesn't hurt if you know two angles in a triangle. You can label the third just in case you need it. Now what I'm going to have to do is to create an equation that involves two ratios of a side to the sine of its opposite angle. How we choose the two ratios? Well, one of the ratios is always going to involve the side that we want to find. We want to find side C, so I'm going to have to use the ratio involving C divided by sine C. So I'm going to highlight what I'm going to use here. I'm going to use C over sine C. So C over sine of 52 is equal to, I know that ratio is going to be equal to any other ratio I make of a side to the sine of its opposite angle. But which one am I going to do? Am I going to do side A over sine A, or am I going to do side B over sine B? Remember, when we make an equation, we only want to have one unknown. Our unknown is side C. So the other ratio I use, I need to know both pieces of information. Notice I don't know side A, so don't use the ratio that involves that side. I know the length of side B, and I know angle B, so I can use that ratio. So 2.5 over sine of 62. And now I've created an equation that only has one unknown. I can solve for that unknown. When you have a fraction equals a fraction, sometimes people find it helpful just to cross multiply right away to get rid of the fractions. But in this case, because our unknown is in the numerator, it's probably easier just to take that sine 52, which on the left we're dividing by sine 52, and move it to the right by doing the inverse operation, which would be multiplying by sine 52. So I would have C equals 2.5 times sine 52, right? That's getting multiplied to the right, divided by sine of 62 degrees. And then we can evaluate that on the calculator to get an approximate answer. And make sure before you're using your calculator, make sure you are in degree mode. So I want to do 2.5 sine 52 divided by sine 62. And we should get about 2.23. I'll keep two decimal places. Let's try another one. Part B, find the length of side F. So side F is across from angle F. Let me actually just label the other sides as well. Here's angle D, across from angle D will be side D, across from angle B will be side E. Now, in this triangle, I see two angles labeled. That means we really know all three. Angle D, if I did 180 minus 46 minus 54, I would get 80 degrees. So I know all three angles in this triangle and one of the side lengths. If those conditions are met, we can use sine law. We just have to create the correct two ratios that we know are equal to each other. If I'm looking for side F, I definitely need to use the ratio that involves side F. So I would pair up side F divided by sine of its opposite angle. So F over sine of 54. And I know that's going to be equal to the ratio of any other side divided by its opposite angle. But which one am I going to do? Am I going to do D over sine D or E over sine E? Since my unknown is side F, the other ratio I make, I can't have any unknowns in it. So I need to use the other ratio where I know both pieces of information. I know side D and angle D, so I'll use that ratio. So side D over sine D will be equal to the ratio of F over sine F. And D is 11, and angle D is 80, so 11 over sine 80. I now have an equation with one unknown. Let's isolate the F by multiplying the sine 54 to the other side. So I have F equals 11 times sine 54 divided by sine of 80. And you can use your calculator, as long as it's in degree mode, to get your approximate value of this. 9.04. Part C says to solve for the length of side X. So I don't even see any angles labeled with letters for this one, but that's okay. If we understand sine law, we should be able to set up the ratios without any letters. I know that the ratio of any side divided by the sine of its opposite angle is going to be equal in an oblique triangle. Once again, I know two angles of the triangle, which means I really know all three because I know they have to add to 180. So this one has to be 82 degrees. And I need to figure out what ratios am I going to use. Well, I want side X, so I'll have to use X divided by the sine of its opposite angle. And then the other ratio I use, I need to know both pieces of information. Well, I know this side length and the angle opposite from it, so I'll use that ratio as well. So when I set up my sine law equation, it would be X divided by sine of its opposite angle, sine of 47, equals 5 divided by the sine of its opposite angle, 51. Isolate X by multiplying the sine 47 to the other side. So I have 5 times sine of 47 degrees divided by sine of 51 degrees. And we can use our calculator to get an approximate answer. And I got about 4.71. And we know the units this time. It's in centimeters, so I should include the units. All right, that's enough practice solving for a side length using sine law. Let's see how we can solve for an angle using sine law. So if we know two sides in a triangle and an angle opposite from one of the two sides, we can solve for the angle opposite from the other side using sine law. So let's see how that works. So notice in this triangle, it asks us to find the measure of angle A. Let me just label the side lengths based on their opposite angles. Across from angle A is side A, across from angle B is side B, across from angle C is side C. If I want to solve for angle A, I definitely need to use the ratio that involves angle A. So I'll need to use the ratio of A over sine A. So 64 over sine of A. Since that ratio has an unknown, angle A, we don't know, that's what we're going to solve for. The other ratio I use can't have any unknowns. I need to find a ratio, a side, and its opposite angle where I know both of those pieces of information. I know side C, and I know the angle opposite from side C. So I can use that ratio. So side C, which is 42, divided by sine of the angle opposite from it, which is 35 degrees. Now we need to solve for our only unknown, angle A. Isolating an angle is a little trickier. Let's actually start by cross-multiplying to get rid of the fractions. So multiply the numerator of the left by the denominator of the right. That's 64 sine 35 equals the numerator of the right times the denominator of the left. So 42 times sine A. And now I'll isolate sine A by dividing the 42 to the other side. So I have 64 times sine 35 divided by 42 equals sine A. And remember, if we know the ratio, but we don't know the angle, we have to use the inverse trig function to find the angle. So I could say angle A would be equal to inverse sine of this ratio, 64 sine 35 divided by 42. Notice I'm keeping this exact until the very end. I'll do the rounding at the end. So angle A, let me use my calculator to figure this out. I get an angle of about 60.93 degrees. And once again, make sure your calculator is in degree mode. Let's try a couple more. Part B says find the measure of angle V. Let me label the sides of this triangle. Across from angle V is side V, across from angle T is side T, across from angle U is side U. In this triangle, I know two sides, and the angle opposite from one of the two sides, we can use sine law to find the other angle that's opposite from the other side we know. So when figuring out what ratios to use, we'll always use the ratio that involves the angle we want. We want angle V, so we'll use V over sine V. And then the other ratio we choose, we need to know both pieces of information. I know side T and angle T. So I'll use that ratio as well, and I can set those ratios equal. That's what sine law tells me I'm allowed to do. So I know that V over sine V, so 11.1 over sine angle V, I don't know angle V, that's our unknown, equals T over sine T. And the length of side T is 5.8 over sine of angle T, which is 31 degrees. Let me cross multiply to get rid of the fractions. Numerator of left times the denominator of the right equals the numerator of the right side times the denominator of the left. And then I'll isolate sine V by dividing the 5.8. And then I'm running out of room here, so let me bring it back to the top. If I know the ratio and want the angle, angle V would be equal to the inverse sine ratio of 11.1 sine 31 divided by 5.8. I get about 80.29 degrees. Part C, I see two sides and an angle opposite from one of the two sides is given. I can use sine law to find the angle opposite from the other side that we know. So when I set up my ratios, I'm definitely going to need to use the ratio that involves the angle we want. So I do 7 over sine theta. And then I would set that equal to the ratio where we know both pieces of information, where we know the side and the angle opposite from the side. So in this question, I could say that 7 over sine theta equals 6 over sine 48. And I'm going to want to isolate sine theta, so I'll start by cross multiplying. Numerator of the left side times denominator of the right equals numerator of the right times denominator of the left. And I'll isolate sine theta by dividing the 6 over. And then I'll calculate the angle that has this ratio by doing inverse sine of that ratio. Inverse sine of 7 sine 48 over 6. I get about 60.11 degrees. Example 3 says find the perimeter of the Bermuda Triangle. If I want the perimeter of this triangle, I'll need to know all three side lengths and then add them together. So let's look at what type of triangle we have. I know two angles. And remember, if you know two angles, you really know all three. These two angles, 74 and 50, add up to 124. Therefore, the other angle would have to be 56 degrees because the angles have to add to 180 degrees. So I know all the angles in the triangle and one of the side lengths. I could use sine law to figure out another side length. And remember, I can't use SOHCAHTOA or Pythagorean theorem here because this is not a right angle triangle. So my only option right now is sine law. So I could use sine law to solve for either side W or side H. We're actually going to need both of them, so we'll do this in two parts. Let's start by figuring out side W. If I want to figure out side W, I'll need to use the ratio that involves w divided by the sine of its opposite angle. And then the other ratio I need to know both pieces of information. I know side D and the angle opposite from side D, angle D. So I'll use that ratio first. So I would set it up as w divided by sine of its opposite angle, which is 50, equals 1600 divided by sine of its opposite angle, which is 56. In this equation I've created, my only unknown is w. I can isolate w by multiplying the sine 50 to the other side. And then I can get an approximate answer for this from my calculator, and it would give me 1,478.4. And my units for this, we know it's in kilometers. So I know w is 1,478.4 kilometers. Let's now solve for h. If I'm going to solve for h, I'm going to need to use the ratio that involves h and its opposite angle. So I'll need to use h over sine 74. So h over sine 74, and I'll set that equal to another ratio where I know both pieces of information. I know that both pieces of information for side D and angle D. So once again, I'll use 1600 over sine 56. And if I isolate h, I multiply the sine 54 to the other side. I'll isolate h by multiplying the sine 74 to the other side. And I could ask my calculator for an approximate answer of this, and it should give me 1,855.2 kilometers. So if I want the perimeter of the Bermuda Triangle, I would need to add all three sides together, and I would get an approximate answer of 4,933.6 kilometers. So hopefully now you know that if you have an oblique triangle, you can't use SOHCAHTOA or Pythagorean theorem. You're going to have to use either sine law or cosine law. This lesson just focused on sine law, and it showed you how you can use sine law to find an angle if you know two sides and an angle opposite from one of those two sides. Or you can use it to find a side length if you know all three angles and one of the side lengths.